Hello students and welcome to session 8 of our course. So last session we had just introduced this particular problem to you, which is a brick manufacturing industry problem, which manufactured three types of bricks, B1, B2, B3, and the unit cost of uh, producing each of the bricks are given as rupees 5, rupees 10 and rupees 8 respectively for each of the bricks, and the bricks are burnt on rotary kiln, and their availability is two numbers of kiln, and then 1 unit of each type of brick. Their requirement is given here, and each kiln is operated for 12 hours per day. So this is what is given. So this can be represented in the form of a table. So I have written all those details represented in the form of a table. As you can see, brick type B1, B2 and B3 are given here. So this is a brick manufacturing industry problem. I am writing the heading on top. And then the requirement with respect to cost, unit cost of producing each of the bricks, which is given as rupees 5 for 1 unit of brick B1. For one brick of B2, it is rupees 10, and cost of making 1 unit of brick B3 is rupees 8. Then, with respect to rotary kiln, number of rotary kilns available is two numbers, and each is operating for 12 hours per day. This is the available or requirement of resources, availability or requirement of resources. Here the available resource with respect to number of kilns is given. The problem says that the company has two numbers of kilns. Each kiln is operated for 12 hours per day. And then with respect to the processing time of the bricks on each kiln is given, that is 1 unit of each brick on brick B1 on kiln is 5 hours, and similarly 1 unit of each brick B2 requires 4 hours of processing on kilns, and similarly 7 hours of processing for 1 unit of brick B3. The total number of available time is 24 hours, which is two numbers of kilns into 2 hours, 12 hours each per day. And then the next requirement was with respect to the skilled and ordinary labor required for the making the bricks, required for making of the bricks, and it says that B1 and B2 bricks require ordinary labors, and 15 men are available on each day. And then each unit of brick B1 and B2 require 12 minutes and 15 minutes of processing by ordinary labor. So this is shown here. So ordinary labor, the available labor is 15 numbers of labor, and each are working for 8 hours. That is given in the problem. And brick B1 and B2 are requiring 12 minutes of processing of 1 unit of brick by ordinary labor, and 18 minutes of processing of 1 unit of brick B2 by ordinary labors. And then for B3 requires skilled labor, and it says that the skilled labor is requiring 22 minutes for making 1 unit of brick B3. And brick B3 does not require ordinary labor. Similarly, bricks B1 and B2 do not require skilled labor. So therefore, for skilled labor against B1 and B2, we have not put their requirement, or their zero requirement for brick B1 and B2, and skilled labor for B3 is 22 minutes for 1 unit of brick B3. Similarly, ordinary labor under brick B3, it is not required at all. Okay, and then how many number of ordinary labor is given here. Each labor can work for 8 hours per day, and there are 4 skilled labors. So that is the availability of skilled labor. So 4 numbers of labor, each requiring 8 hours per day for is the availability of skilled labor. So we have written these constraints. So we have totally cost per unit given, number of kilns as one of the constraints, skilled labor requirement as one constraint, ordinary labor requirement as one constraint. Then the next part is it says each unit of brick B1 produced will generate 20% of wastage. That is, only 80% of the bricks are available for selling or for use. And then similarly, each unit of B2 and B3 will require 10% and 20% wastage. So this is represented as wastage percentage. Against B1 it is 20%, against B2 it is 10% and 14%. So wastage has been shown separately. That means whatever is being produced, only minusing the wastage, the balance is being sold, or balance is being used for ready for use. So that is what we have to understand by this constraint. Then the last statement that is given is profit from selling 10 units of bricks. That is, instead of giving per unit of brick, they are giving 10 units of bricks or 10 numbers of brick. By selling it, profit is rupees 50 for B1. That means we have to convert that as per unit of brick. This is indicating C1 component. So it is 50 by 10, which is rupees 5. And profit from 100 units of bricks B2 and B3 are 200 rupees and 250 rupees, meaning the profit per unit of brick B2 is 200 by 100, which is rupees 2, and profit of 100 bricks of B3 variety is rupees 250. Therefore, per unit of brick B3 will produce a profit of 250 by 100, which is 2.5 rupees. And the total budget available with the company for each day is rupees 1 lakh. So this budget constraint is important, or is related to, or will be related to the cost component that is given as the first statement. So we have to write down that unit cost is given and total available budget on hand is 1 lakh. And then unit profit is also given to us. So that is where we have to take or extract the decision variables. So we can see that the problem has one cost constraint, kiln constraint, skilled labor constraint, ordinary labor constraint, and also there is a wastage component of whatever is being produced for each type of brick as different percentages. And finally, unit cost of production. So whatever we have read through the problem, we have extracted that information and presented in the form of a table. Once you give it in the form of a table, it is easy to retrieve the data and put it in the LPP format. Okay, so what is that we have to finally find out? So the hint here is the unit profit is the hint. So people may get a doubt why unit cost and unit profit is given here. Here unit cost is relating to the budget restriction or budget limitation constraint, and therefore that is a constraint. Whereas the objective function is actually the maximization type, and that is seen through the unit profit per production of each of the types of bricks that is given to us. Therefore, from this also we can identify which is our decision variables. So decision variables are going to be how many number of bricks that of B1 variety will have to be manufactured, can be taken as X1. The number of B2 bricks to be manufactured per day can be taken as X2. Number of B3 bricks to be manufactured per day can be taken as X3. So that is what is listed here. X1 is number of units of brick type B1 per day to be manufactured. X2 is number of B2 to be manufactured per day, and X3 is number of B3 to be manufactured per day. Then the objective function is going to be, this is most important to be seen, objective function has got a cost profit component and a wastage component. So whatever is being produced is not totally sold. Only 80% of that is being sold with respect to B1, and whatever is being produced, only 90% of it is sold for creating profit with respect to B2, and whatever is being produced is only 86% being sold for creating profit, because 14% is wastage. So this has to be this component has to be brought into the objective function. So how do we bring that into the objective function? We can write as usual the objective function incorporating the profits. So our objective function is going to be 50 by 10 into x1 plus 200 by 100 into x2 plus 250 by 100 into x3 minus 20% of x1 minus 10% of x2 minus 14% of x3, because these three are the wastages of whatever is being produced. So therefore our objective function is going to be like this: 50 by 10 x1, because this is our C1 component, which is unit profit multiplied by number of units produced. So unit profit is for 10 units 50 rupees, therefore for 1 unit it is going to be 50 by 10 into x1. Similarly with respect to B2, it is 200 for 100 units, it is 200 rupees, therefore for 1 unit it is 2 rupees into x2, and for 100 units of x3 it is 250 rupees, therefore for 1 unit it is 2.5 into x3 minus the wastage component has to be taken. It says 20% of whatever is being produced, therefore 20% of whatever is being produced. What is that? 20% of the profit, which is 5 by x1, which is got here. So the total profit will be total profit minus the wastage component. So 20 by 100, that is 20% of whatever is the profit, which is 5x1 minus 10% of B2, which is 2 times x1. 10% of the profit produced is 2 into x1. So 10% of that is wastage. Similarly, 2.5 into x2 is the profit of producing B3. In that 14% is wastage. So minus 14 by 100 into 2.5 x3. Hope students you are understanding this term. And then you are simplifying that into an equation like this, a linear equation. And then we have the first constraint, which is budget limitation constraint. So with this, which is with respect to budget, it is 5x1 plus 10x2 plus 8x3 less than equal to 1 lakh. So because the available budget on hand is 1 lakh, so that is shown in this first constraint. Second constraint is with respect to availability of kilns. So we can see that it is 5 into x1 plus 4 into x2 plus 7 into x3 less than equal to 24 hours per day. So that is what is shown here. And skilled labor constraint is 0x1 plus 0x2 plus 22x3 in equal less than equal to 4 into 8, which is 32 hours. So 32 hours is given here. This is in 22 minutes. So we are converting that into minutes, so that everything on the left hand side and right hand side are same. Then the next constraint is with respect to ordinary labor, which is only available for B1 and B2. So it is 12x1 plus 18x2 plus 0x3 less than equal to 15 into 8 into 60 minutes. So these are the 4 constraints for our problem, and we have incorporated actual profit by subtracting the wastage of the components that is being produced. So finally x1, x2, x3 is greater than equal to 0. Thank you students. Hope you are understanding this example.